Okay, here we go. This is the 2013 Maths Methods Exam 2. This is a run through of the multi-choice questions. As always, we're using the ClassPad 2. And here we go. Question 1. The function with rule f of x equals -3 tan 2 pi x. So work out the period. The period of a tan graph is pi on n being 2 pi, so pi on 2 pi equals a half. And I'm putting the percentage of people that got it right from the examiner's report. As always, it's a good idea to check the examiner's report out as well. Okay, question 2. The midpoint of this line segment between 1, -5 and D2. To work out the midpoint, you would find the halfway distance between the two x coordinates and the y coordinates. So halfway between 1 and D is 1 plus D divided by 2. So it had to be A. I haven't bothered working out the y coordinate because the only one with D plus 1 over 2 was A. Moving on, we're told that x plus A is a factor of this cubic here. So where A is a real number and not 0, so what is A? So if if x plus A is a factor of this cubic, it means that if I subbed -A into this cubic, the result would be 0. So that's what I'm going to do. So 7 times, I'll get my variables up, -A cubed. I wouldn't have to use A here, I could just use X or Y, it doesn't really matter. 9 times -A squared. Minus 5 times A times -A. Always good to use lots of brackets. Now we want to set that equal to 0 and solve. So action, advance, solve. Set that equal to 0 and we are solving, where's the comma, solving for A. And the answer is 0 or 2. Now 0 is not an option, plus we're told that A couldn't be 0, so the answer is 2, which is E. Moving on, we have a graph here which is given by the rule 3 minus e to the x, and we want to know which one's the inverse. So easiest way to do this, look at the asymptote. So we've got a horizontal asymptote of 3, which means the inverse would have to have a vertical asymptote of 3. So that narrows it down to a few options. And we know that the y-intercept is 2, so in the inverse the x-intercept would have to be 2. So that means that the answer is E. Question 5, we have two functions, f and g, a log graph and a square root graph, and we want to know what's the maximal domain of f plus g. So if you know your sums and products of functions, the domain of f plus g is the intersection of the two domains. So the intersection of -∞ to 1 and -1 to infinity. So the set of all numbers that are contained within those two sets. So if this goes from -∞ to 1 and this goes from -1 to positive infinity, then a set containing numbers that are in both would have to be -1 to +1. So that was A. Most people got that right, which is good. Question 6, average rate of change. So y2 minus y1 over x2 minus x1, just like finding gradient. We'll sub 5 into this function and we'll sub 1/4 into this function and divide by 5 minus 1/4. So calculator will do those substitutions for us. So sine of 2 times pi times, I'm actually just going to put x in for now, plus 2x, and what we want to do is we want to sub in, so we're going to use the given that button, we want to sub in 5, and we want to sub in, we want to sub in 1/4. So not necessarily the quickest way to do this, but I just want to play around with the given that button. So 10 minus 3 on 2 divided by 5 minus a quarter. We should probably put that in brackets. So 10 minus 3 halves minus, divided by 5 minus a quarter gives us the answer, which is 34 on 19. Okay, moving on, we've got a sine function that has a domain of negative a to a. Now, what's the largest value of a that will mean that an inverse function is still defined? So if we know anything about inverse functions, we know that they're only defined if the original function is 1 to 1. So what I could do is have a quick look at the graph of sine 2x minus pi on 6. Let's see what we're looking at here. Okay, so that's what it looks like. Now, you should be able to see that the value for a, the domain can only go as far as one of these turning points. So really, I can't make a any bigger than what that little minimum down there has to be. So what I could do is I could find what that minimum is, and it's at negative 0.262. I think that says 0.26. Oh yeah, it's down here, negative 0.262. And if I find out what that is, that's going to be my answer, and I can find out quite easily that pi on 12 is 0.262, so it had to be pi on 12. Question 8, we have a probability question. So when Xenia travels to work, she either drives or takes the bus. So if she gets the bus, the probability she'll get the bus again is 7/10. If she drives, the probability she'll drive again is 3/5. So quite easy to draw up your transition matrix there. This is bus then bus, so 7/10, so that would make that 3/10 and so on. So the long-term probability that Xenia will have to take the bus, we can use the steady state formula. Look it up if you don't know what it is, but it'll be 2/5 divided by 3/10 plus 2/5, and that'll be the long-term probability that Xenia takes the bus to work. The long-term probability that Xenia drove to work would be 3/10 divided by 3/10 plus 2/5. I'm not going to type that in. The answer is 4/7. Question 9, we have a soccer player who practices penalty kicks. Each time he takes a kick, the probability he scores is 0.7, independent of any other penalty kick. And he took 20 penalty kicks. By now, you should realize that this is a binomial distribution. So given that he scored at least 12, what's the probability that he scored exactly 15? So we want exactly 15 given that he scored more than 12, which is going to be the probability that he got exactly 15 divided by the probability that he got at least 12. So if we work those two things out using the calculator, we'll have a binomial PDF for exactly 15. So 15 out of 20 with a probability of success of 0.7, and we can use a binomial CDF for from 12 to 20, number of trials 20, and a probability of success of 0.7. If you're wondering with the first one, 15, yes, I could have just done 15 and 15 here, so I could have used CDF for both, but I didn't. So divide my two answers and I get 0.2017, which is the answer. Okay, moving on. A bit of a mistake in this question. I'll point that out in a sec. So we're still on probability. For events A and B, the probability of A intersects B is P. Probability of not A intersects B is P minus 1/8, and so on. So we draw up a quick Venn diagram here, which looks like that. And we're told that A and B are independent. Now we know if two events are independent, the probability of A multiplied by the probability of B is equal to the probability of A intersect B. So that means that 3P on 5 plus P multiplied by P minus 1/8 plus P, that should be a P, is equal to P. So if I type that into my calculator, I will get the right answer. So I'll just use, I will use p. So 3p on 5 plus p multiplied by p minus 1/8 plus p equals p. And we want to solve that for p. So, whoops, put a comma, p, and we'll chuck the word solve at the front, which I probably should have done beforehand, but it doesn't matter. So solve that for p, and I get 0 or 3/8. I was now this is interesting because p, the intersection could technically be 0, but we have been told that a intersect b is p minus 1/8. So if p was 0, then that probability would be less than 0. It'd be negative, which doesn't make sense. So the answer is 3/8. So 0 was not an option. So C is right. Moving on to question 11. So if the tangent to the graph of y equals e to the x at the point x equals c passes through the origin, then what is c? So let's work out what the tangent is. So we'll go to, actually we use interactive for this one, interactive calculation line, tan line, and we'll type in e to the a times x. I'm not sure if you need the times in there or not, probably not. But it's good to do anyway, just in case, because sometimes it thinks you actually mean AX, which would happen if you were in ABC, but anyway, I'm rambling. So moving on, we want it at the point C. So you actually get that. That's the equation of the tangent. Now, if the tangent passes through the origin, then what does C equal? So if the tangent passes through the origin, that's the equation of the tangent, then that means that when y equals 0, x is 0. So let's change the x's to 0s, there's only one, and set it equal to 0, and we want to solve for c. So let's see what happens when we do that. We get c equals 1 on a, there's the answer, 1 on a. Okay. Now question 12, this is probably the hardest question on the paper, well the multi-choice section anyway, so I'll try to explain it best I can. We're told that y is equal to 4 cos x and x is a function of t such that dx dt equals 3e to the 2t and x equals 3 on 2 when t equals 0. So what I'm going to do, let's just worry about this bit here. So dx dt equals 3e to the 2e and x equals 3 on 2 when t equals 0. Let's treat that like a anti-differentiation problem. So we're going to work out what x is in terms of t. So what we'll do is we'll anti-differentiate 3e to the 2t. And that's pretty easy to do on the calculator. So 3e to the 2t. Now be careful here, if you're using t, you've got to tell the calculator that you want to anti-diff in terms of t. So we'll put a comma t, otherwise it wouldn't have worked. So 3e to the 2t on 2, and of course there's a plus c there, so I've just written that here. So x is equal to 3 on 2e to the 2t plus c. So let's work out what c is. If t is equal to 0 when x equals 3 on 2, so sub that in, t is 0 when x equals 3 on 2, you're left with 3 on 2 equals 3 on 2 plus c, because e to the 0 is 1. So c is actually 0, so that's good news. So x is equal to 3 on 2 e to the 2t, which means that my function y equals 4 cos x is really y equals 4 cos 3 on 2 e to the 2t. So now we can work out dy dt by differentiating 4 cos 3 on 2 e to the 2t. So I'm going to differentiate that. I'm sure there's more than one way to go about this question. This way kind of makes the most sense to me. So 4 cos, so if we differentiate that, remember that we want to tell the calculator to do that in terms of t. We get this weird thing here, and we want to know what dy dt is when x equals pi on 2. So when x equals pi on 2, we want to sub something in to here, but we can't sub in pi on 2 because x is pi on 2. So we've got to work out what t is when x is pi on 2. So we're actually going to go back to this is my function for x. So x equals 3 on 2 e to the 2t. And I'm going to sub in pi on 2 in for x. It's about to get a bit messier. So we're going to solve this for t. So we'll put a solve at the front there. Come on. And we get that. So what we need to do is we need to sub log of pi on 2 minus log of 3 on 2 into here. And this is when the given that function is really, really helpful. So we're going to drag that down and we're going to go given that t equals this thing here. Okay, and then that gives us negative 4 pi, which is the answer. So only 35% got that. So if you did a little bit more work, you could have given yourself a bit of a leg up in this exam. But that's heaps and heaps of work for a multi-choice question, so you might be wanting to leave that one till last. Onto an easy one. If the equation f of 2x minus 2f of x equals 0 is true for all values of x, what could f be? So really, if you have a little scroll through them, it kind of had to be this one. 2x, 2, if you sub in 2x in for x, you get 2 times 2x, and if you just do 2 times 2x, you get the same thing. So 2 times 2x minus 2 times 2x, 0, which is what you wanted. Okay, don't even bother subbing anything in for the other ones. 14, here we have a exponential graph, 2 to the x plus c, and the area of the shaded rectangles, so it's a left endpoint question, and we're told that the area is 44, so what would c have to be? So the width of each rectangle is 1, so this rectangle is going to be 1 multiplied by 2 to the 1 plus c, which is the y coordinate there. So 2 to the 1 plus c is just 2 plus c. So the 4 rectangles, the area would be 2 plus c plus 4 plus c plus 8 plus c plus 16 plus c equals 44. Solve that for c, which I won't bother doing on the calculator. It's 7 on 2. Question 15, another graph one. This time we're told that the average value of the function is 2 from the interval 0 to 6. So which one is could the graph be? Now, if you know anything about average value of a function, you should know that if the average value is 2, then if I draw a horizontal line at y equals 2, then the area above has to be the same as the area below. And so you straight away tell that it can't be this one. It's probably not this one. It's definitely not this one. I won't even bother looking at E because the answer is C. So if you draw my line there, the area above and the area below are the same two triangles. So the answer was C. Let's see, most people actually thought it was A, or more people thought it was A. And if I had to continue this graph onwards until I went to here, then that answer would have been correct as well. But it's not. So question 16, again, a bit of a trick question here. The fourth most popular response was the correct one, which is very unusual. So we've got a graph from 1 to 5, the square root of x minus 1. Here it is here. What's the area of the shaded region? I'm going to show you two different ways to do this one. So if we're going to do it the proper way, we could find the area using the inverse. So if I find the inverse of the square root of x minus 1, the inverse is x squared plus 1. So the area of the shaded region would be from 0 to 2 of x squared plus 1. Now, of course, the problem is that we've got this box here. So we'd have to, it's actually area between two curves. So the area would be x squared from 0 to 2 of x squared plus 1 minus 1. Okay, so that's sort of the proper way to do it. But what you could have done, if you had no idea about that, was just find the area. So the area is the area from 1 to 5 under the curve of root x minus 1. Now, of course, this isn't the area, but I'll get to that in a sec. So what I'm about to find here, that would be the area underneath the curve, okay? So, but the area I'm looking for would be the area of that rectangle minus the area under the curve. So it's actually, the area of the rectangle would be, it would be 4 times 2, which is 8. So 8 minus that is the answer, is 8 on 3. So all you'd have to do then is work out which one of these gives you 8 on 3. So I'm not going to try each one, but unfortunately the answer was E. So if you did try each one, you'd get all the way to E before you had the answer. But if we do this one, we get 8 on 3, so it had to be E. So 2 ways to go about that one. Question 17, A and B, more probability. So they're events of a sample space. Given that given B is equal to P, probability of B is P squared, and A is P 1 on 3. What's B given A? All right. So the probability of A given B, which is P, the formula for that would be A intersects B divided by the probability of B. And the probability of B is P squared. So P equals the probability of A intersect B over P squared, which means that the probability of A intersect B is P cubed. So therefore, the probability that B given A is the probability of A intersect B over the probability of A. So that gives you P cubed over P to the 1 on 3. And 3 minus a third is 8 thirds. So the answer was D, which 49% of people got right. Okay, 18. This is similar to a question that we did a little bit earlier. So if g of x is log to the base 2 of x, which one is true? So what you could do, work out what is 2g of 8x. So 2g of 8x is 2 times the log of 8x. Okay, so you could do this on by hand, or maybe the calculator will help you a little bit. I've done it by hand. So you take the 2 up and you get log 2 of 64x squared, because 8x squared is 8x all squared is 64x squared. So that's the same as log of 64 plus log of x squared. Log of 64 is 6. Log of x squared is the same as g of x squared, isn't it? Because a log of x, and we've got log of x squared. So the answer was B. Okay, moving on to question 19. And now from memory, a lot of people had problems with this question because the graph was quite difficult to draw. This value of T3 was quite high. So I'm going to show you a different way to do this one. So we know that e to the x root 3 sine x is shown here. And we want to know what's the x coordinate of T3, which is the 1, 2, 3, third stationary point. So what you could do, you know that the stationary point is when the derivative is equal to 0. So what you could do is differentiate it and set it equal to 0 and find where the stationary points are. And it's the third one. So I'll show you what to do. Whoops, I'm still in the exponent. So get out of that. Sine of x. So if I differentiate it, I get this horrible looking thing here. And if I set that equal to 0 and I solve, what happens is I get a general solution, which is not what I want, but what I can do is right at the end is I can go, well, given that, I just want to know what all the solutions are between 0 and say, I don't know, 10. And that happens to give me 1, 2, 3, the first 3 stationary points. If I had have made that something else, like, I don't know, 20, would have given me a few more stationary points. It wouldn't matter. I want the third one. The third one is 17 pi on 6, so the answer is 17 pi on 6. Okay, so you might think that's probably a longer way to do it than just by graphing it, but I know some people had issues with the graph, so try both. Okay, question 20. This is a really interesting one because 53% of people got it wrong, so it was a bit of a trick question. The reason it was a trick question is because it asks you to find a it gives you a transformation, but find a function that when you use that transformation, it maps the graph of the function onto x squared. I think what the majority of people did here was they applied the transformation to x squared, and if you do that, you get this. Okay, but what we want is we want to find a function, which was this one, that when you apply the transformation, you get this. So what the transformation was a reflection in the x-axis and a translation of 5. So if I take this graph here and I reflect it in the x-axis, that negative becomes positive, and then if I move it over by 5, this plus 5 disappears as well. So the answer was actually A. But a really big trick question. Alright, 2 to go. Question 21. We've got a cubic ax cubed minus bx squared plus cx. I want to know when does this function have no stationary points. So the function will have no stationary points when there are no solutions to the derivative. So I'm going to differentiate ax cubed minus bx squared plus cx. Just do that by hand, it's quicker. 3ax squared minus 2bx plus c. So when this quadratic has no solutions, there'll be no stationary points. So this will have no solutions when the discriminant is less than 0. So the discriminant would be given by b squared minus 4ac, which is minus 2b squared minus 4 times 3 times c. So what I can do is solve that in the calculator. So I'm going to go negative 2b squared, which is positive 4b squared, so I could just write that, minus 4 times 3 is 12, minus 12c. Now I want this to be, what have I forgotten? I've forgotten an a, sorry, there should be an a there, shouldn't there? 3, so it should be 12ac, so 12 times a times c. And I want that to be less than 0. What am I doing? Less than 0. So I'm going to solve that. And what do I want to solve for? I want to solve for c. So if I solve that for c, I get that for some reason it's told me that a times c has to be greater than b squared on 3. So just take the a over, and you get b squared on 3a. So it had to be, c has to be greater than b squared on 3a, which was D. Okay, final question. We've got some butterflies that die T days after hatching, mean of 120 days, and standard deviation, we don't know what that is. So out of 2,000 newly hatched butterflies, 150 are expected to die in the first 90 days. So if I pick a butterfly at random, the probability that it will die in the first 90 days is 150 out of 2,000. Okay, and 150 divided by 2,000 is equal to 3 on 40, or 0.075. So I can use an inverse normal distribution here to work out what my z-score is. So I want to know z is less than what gives me a probability of 0.075. So the answer is that my z-score is negative 1.439531471. So using the z-score formula, 90 minus 120 divided by the standard deviation is that. So if I solve that, I'm not going to bother. If I solve that in the calculator, I get 20 point something, which is closest to 21 days. Okay, and that's the end of that exam. I hope that was useful. There are quite a few tricky questions in here, so if you want any of them explained a little bit better, feel free to leave a comment, have a look at the examiner's report, and thanks for watching as always. and best of luck with the exam.